Good morning, everyone. Thanks for coming here. If you want to learn all about cow poo, come in and grab a stool. Sorry, that was poor. So Brona initially asked me to talk for 45 minutes about dung beetles from a farmer's point of view, which I was all excited about, but I kind of had to think about the audience. And to be perfectly honest, I think he'd get bored long before I would. So I decided to change the briefing a bit. So I'm going to look at livestock poo and from a number of hats from different points of view, because it's a whole world going on. So I suppose we have it here. A little bit maybe about who I am. First of all, my name is Bruce Thompson, named after Norman's, the previous speaker's dog. um, Everyone knows a dog named Bruce. So, who am I? Well, I've been asked wondering this myself for quite a long time now, and I seem to get more confused as time goes on, but just a quick background who I am. I studied engineering in college, came home then and expanded our dairy herd from 54 cows up to 300, which brought some challenges in terms, particularly parasite control was one area we were really looking at, and myself and Dad arguing over what the best approach was. So with that, I decided to investigate it a bit further and applied and got a Nuffield Scholarship, which allowed me to study that area, and subsequently then became a member of the Cows Steering Group, which is it's a steering group with information in the UK for advice for farmers and best practice in terms of parasite management. They have a very good website. And the other side of the border then, the other hat, Animal Health Ireland's technical working group on parasite control, basically the same thing. And then I do a bit of parasite consultancy with farmers and vets. And last year I just finished a diploma in climate change, the environment and agriculture. I have to write that down because I forget what it was. So if I was to look at that, basically I would say I'm a dork. So that's who I am. But I suppose, look, the focus for today maybe is around what I did with as a Nuffield scholar and what I was looking at. So my topic was, can anthelmintic resistance mitigation measures benefit the environment through the employment of grazing strategies and dung beetles? I probably didn't think that heading out very well, but it just rolls off the tongue. So I suppose for my first part of today, I'm going to put on my scholar hat. So that's the first hat. My 9-year-old son helped me with this one. What a mouthful of it was. And my first task was to figure out what anthelmintic resistance was, and then my second task was how to pronounce it. So I suppose we're well used to looking at this life cycle of parasites on farm. So parasites go into the animal, come out the back end, go out onto grass and hatch, and the animal ingests it then a few weeks later, and it goes back into the animal again and multiplies. But we've been spending 3 generations focusing on this area, which is within the animal itself, which is, look, it's been fine. We see that our animals have parasites. We go in with a wormer and a product to kill the worms out of the animal. At any given time, there is only about 10% of the parasites that are on a farm are in the host. The other 90% are out on the pasture and free living stages. That's a very rough figure now. But look, I suppose the products we use, they're cheap, fast and satisfying, which is a bit like my first girlfriend. So it has worked fine. But the issue is now that the parasites that we've been treating with these products are becoming resistant to the products we're using. So in other words, when we use a product, we expect it to kill all of them within the host, but there's always a small percentage left, nearly always a small percentage left. And if that percentage is below 5%, we've no problem. But once it gets above 5%, then the product is deemed that there's a resistance problem there with that product. So what we are doing then when we use the product is we are leaving behind a number of animals that are or a number of parasites that are resistant to the product. Now that resistance is a genetic trait. So as those parasites left behind, they start to breed and multiply, and you end up growing this gene pool of parasites that are resistant to the product. We have three parent products that we use on the parasites, and there's 5 in sheep, 3 for cattle, 2 for dairy cows, and there's only 1 you can use in a milking cow. So if we get resistance to one of those products, we're in trouble. And every time we use it thereafter is another time that it won't work. I hope I'm explaining that well. That's the real difficult part to try and get your head around. And if you don't understand, I'm sorry. It's my fault for not explaining it very well. But I suppose to put it into context, so there's people in the room here. There's probably some people in this room that actually like pineapple on their pizza. Yeah, I know. They walk amongst us, but and they think it's acceptable. But if you were to remove everyone from the room here that didn't like pineapple on pizza, which is basically all the normal people, and you're left with 4 or 5 Egypts, and they start breeding amongst themselves, you were then increasing the gene pool of people that will actually think it's acceptable to put pineapple on pizza. Whereas if you hadn't done it, the gene pool would have been a lot less. So the percentages of the people that eat pineapple on pizza will be a lot higher if you remove them from the equation, remove the normal people from the equation. So it's the same principle then with selection by worming. So basically, if you're worming, you're selecting for resistance. So anthelmintics, that's the word that covers these products. They're a medicine. They're a really important medicine. We should be treating them like antibiotics. My farming system would find it very difficult to operate without them. One of my first tasks was to figure out what level of a problem we had in the country. And Chagas, our research centre down south, did a trial on the dairy to beef livestock, and they found resistance on all 24 farms that they did the trial on. So it is a problem, and it's growing. We've also, Trinity College did a bit of research testing groundwater, and found some of the parent products of one of the products in groundwater, which is a bit alarming. Now, it was below a tolerance level, but I think the fact that it's there at all is concerning. And just recently, when I was doing my research, I was told that it's impossible for lungworm, so we've all heard of hoose. I was told that it was impossible for lungworm to become resistant because it's so easily killed with an anthelmintic. But very recently, last few months, there's a trial work showing that it looks like it's actually happening. So that it is a big problem. So I suppose to look at the first stage, where the eggs come out of the back end of the animal and out onto pasture. And like I said before, this is where 90% of the parasites are, is out in the free living stage. So I was looking at how can we interrupt this process. So I suppose the next hat, any excuse. My ecological hat. Or ecologist hat. So inside these dung pats. So dung pat goes out onto the soil. We have plenty of insects, worms, nematodes, trematodes, cestodes, eggs, you name it, it's in there. Some of them are beneficial, Some of them are predatory. Some of them are they're nuisance. So we've nuisance flies, but they all have a role. They all use this pat as it's an ecosystem, and some of them use it as a food source. Some of them use it as a habitat, and even there's mushrooms growing in them, which we're going to put a pin on. I'll talk about later on. But I suppose, look, the one thing that they all have in common is that they break down that dung pat, and if they're not there, they won't do it. So they're very important. All these insects have a role to play. The one that I focused on was the dung beetle. So we have two different types in Ireland. There's just under 50 species, but we've two different types in Ireland. We've dwellers and tunnelers. So the tunnelers, they would bore down into the ground, and they bore holes that can go over 1 meter down into the soil, bringing the cow poo down into the soil, and they lay their eggs in little balls in under the ground. So immediately you can understand that in doing so, they're removing those parasite eggs that I was talking about from the pasture. So bring it down into the soil. They're putting the dung pat that is full of nitrogen, phosphorus and potassium, they're putting it down at the roots of the grass. So it's no longer a noxious weed on top of the soil, it's now a food source for grass and herbage in the soil. And they're also aerating the soil. The dwellers then, they live in the dung pat, and they lay their eggs in the dung pat or just below it on top of the soil. And that's where they work. So the benefits to farmers are parasite and fly reductions. So the obvious thing is the tunnelers that bring it down into the soil. So once they're gone out off of the grassland, it's pretty obvious what's happened there. The dwellers then, they don't actually eat the dung. We think that they're eating the dung pats, but dung pats are about 80% moisture. What they're doing is actually drinking the pats dry. So what these parasites I'm talking about, they're aquatic, so they actually swim out of the dung pat out onto the grassland. So if they have the dung pat dehydrated, it really interrupts the process of actually moving out onto the soil. And also in doing so, in drying out the dung pat, it leaves it more attractive for earthworms to pull that pat down into the soil, which is eventually what happens. Earthworms won't go near a fresh dung pat, but they will go to one that is about medium rare or maybe slightly well done. In burrowing, the dwellers actually aerate the soil, so they're bringing these holes down into the soil, which helps aerate it. There's also on the bottoms of the bellies of these insects, there's these tiny little mites. They're called phoretic mites. If you don't know what they are, someday you definitely will. When we're all 6 foot down below the ground, that is eventually what degrades our body, is phoretic mites. But the problem with those phoretic mites is they find it very difficult to migrate around the farm. So they use these dung beetles as a taxi to move from one dung pat to the other. So there could be 20 or 30 mites on one of these beetles, and the mites actually they eat the fly larvae, and they eat parasite eggs. So they're really a real predator of the parasites. And in removing the dung pat from the soil, we see that there's less of an opportunity for nutrient runoff into the waterways, which is a big problem nowadays. On my travels, when I was researching with Nuffield, Burney City Council in North Tasmania put a lot of money in importing dung beetles into North Tasmania because they had a problem with algal blooms in the waterways, and the cattle and the sheep were grazing alongside the water, and in the catchment area there was runoff because they have the same level of rainfall as here, but it comes in higher volumes at a given time, and was washing the nutrients into the waterways, and they were getting this algal blooms growing. So the council funded the importation of dung beetles, mass rearing and releasing of dung beetles to remove those dung pats off of the soil. And it was quite incredible to see what they were able to do. And I suppose then the real, I suppose, sell story with them is these dung beetles they're at the bottom of a food chain. So they're a food source for birds, bats, badgers and foxes. So they're really turning I suppose, a waste product into an ecological service. So I think it's very important to mention that. Like our cows are, when you think of the whole cycle of turning grass into not only meat and milk, but also turning it into a food source for the wider ecological sphere. So here's your chough bird. And this bird is actually in decline up in around Scotland and Ireland, Northern Ireland. But they feed on these little larvae. If you see them there on the left, they are they're the second stage of development of the dung beetles. So they're laid in an egg, they hatch into this larvae, and then they develop into a dung beetle. And you can see there's your chough bird with one of those larvae in their mouth. Particularly at this time of the year, if you go out to a field pasture and look at the dung pats, you will notice some of them have holes in them. People think that those holes are dung beetles burrowing. They're actually not. They're from possibly starlings picking the larvae out of dung pats. So next time you're watching a murmuration of starlings, and very often they'll come down to a field and they'll go back up again. And that's what they do in the process. On my own farm, here's a fox scat. And if you look, you can see the remnants of dung beetles in it, the shells off of them. So that's what my cows are doing. So they're providing a food source for foxes. So I suppose, as part of looking at how we could increase the dung beetles on my farm, I looked at a mass rearing program and took learnings that I found in South Australia, in Tasmania, and New Zealand about mass rearing. I brought them home to my own farm, collected dung beetles and mass reared them. It was a pretty good experiment. We got a multiplication rate of 19.8 to 1. So for every dung beetle we caught, we were releasing 19.8 dung beetles. So it was successful. We were trapping the native species that I found on my own farm to do it. And I also, it did take a lot of work to do it. It's not for the faint-hearted, so it's not something I'd sell to other people. But if you are going at it, I would say that cheap labour is essential. And I found, a few snacks and a few kids are great. Child labour is an excellent way of getting stuff done. We might have had a few accidental releases, early releases, and a few tantrums and shovels thrown, but look, we got it done. It was great fun getting the kids bringing them home to their mammy at the end of the day covered in cow shit. But we also then caught this beetle up in the top left is it's a burrower. That's the one I was talking about that burrows down into the soil, and I had to get special permission to capture them from 2 counties away, and brought them onto my farm from Department of Agriculture. And I mass reared them in a incubator. Actually, the incubator's on the last slide, the bottom left one. That's one of the incubators. But what I found was, you can see there top right is a fresh dung pat put into the incubator, and 3 days later, underneath it, that's the same dung pats, completely gone into the soil. So they're well able to remove it when they're put in the right conditions. That's temperature controlled. You can see in the bottom left there in a box, I just used one of those plastic boxes just for interest's sake to see what they were actually doing. And you can see there that the channel where it's going diagonally, a tunnel where they brought down the dung pats and they made a chamber then. So you can imagine what that is doing for soil health and removing pests off of the ground. So the next stage then is these these parasites, then we're going back to parasites, and how they move onto around the farm. And look, grassland management is an important part of that. So that we're done with the ecologist hat, and I'm putting on my farmer's hat. So yeah, look, our current strategy of grazing once every 3 weeks, moving around the farm, rotating, short leafy grass, damp climate, it's a perfect haven for parasite reproductive. So I wanted to try to see if we could interrupt that a bit somehow. So I came up with this idea. It's called traffic light grazing. I think this is a great idea because I came up with it. But basically, it's just managing the risks on the farm. So where we think the parasites might be, where the heavy loadings are, what are the susceptible animals, most susceptible animals, different times of the year, different hatches, different parasites, and it's mapping them on a map. It is quite complex, I'll admit, but it reduces the amount of worming we need to do to our animals and increases their performance by doing so. If you see here, no PowerPoint is a PowerPoint without a graph in it, so without a boring graph. Basically, what this is showing, this graph is showing that the result of trial work where animals that were on a continual grazing and worming strategy didn't perform as well as animals that were put on a grazing, low-risk pasture and no worming strategy. So, in other words, there's better performance to be had by managing the grassland rather than managing the parasites in the animal, with everything else pushed to one side. So, basically what happens is we put a map on the farm. We did it with a group of farmers, and they mapped the risk in terms of red, yellow, and green, and that map evolves then as the season goes on, and is brought into the next season then. So just try to simplify it. Here's my calves out on my farm grazing. I just wanted to show you here that the height of the grass. So grazing height has a lot to do with parasite management as well. So the majority of parasites are in the bottom 5 to 6 centimeters of herbage, and on my farm we're trying to graze down below 4 centimeters. So you can see there's a red flag there straight away. So with our young stock, which are the most susceptible, we don't let them do that. We have a higher cover of grass in the spring for those calves, and we move them throughout that. We don't force them to cut down grass. There's no dedicated calf paddock on our farm, so we're moving them around. It's very fluid. We're trying to avoid. You can see on this other graph. Love graphs and PowerPoints. We're trying to avoid the spring rise of infective larvae put out by young stock early on in the season, hatching into larvae, and then the young stock coming back out onto that same pasture and ingesting them. That's where a lot of us fall down, and it's so easy to do inadvertently. So with that then, I'm going to take off my farmer's hat. I'm going to play the vet. That's what my vet always wears, so I couldn't think of it. Maybe I have bad lights in my house. I'm not claiming to be a vet, by the way. So we look, our livestock, our cows in particular, the word vaccine is derived from the Latin word for a cow, which is vacca. The first vaccine made was a smallpox vaccine. It was developed using cows to enhance it, or to develop it. they're really good at developing immunity, cows are. So once they come up against a pathogen, they will create an immune response, and they're really good at it. The problem is we need to be able to balance the exposure with immunity. So if we overwhelm them, they're going to get sick, and that's why we end up going in worming. But they should, if they're gradually introduced to parasites, they will build up their own immunity to them. So I lost my train of thought there, sorry. So what we need to do is control the risk and the risk stock in terms of what they're coming up against. Lungworm vaccine. There's a vaccine for lungworm, which is made out of lungworm. In fact, you give it to animals, and they create an immune response. So you're giving them irradiated lungworm. You're drenching them with it, and then they build up this immune response, and it works really well. So it just shows it's the same with other parasites. Come up against it, and they'll create their own immunity, but it's controlling that environment, that they're not being overwhelmed with it. So, look, we have to think that they've two different types of immunity. They have innate, that's what they're born with. So different, same with humans, some of them are going to be genetically predispositioned to resist parasites more so than others. That's hereditary as well, so it passes from one generation to another. So I suppose we've been using wormers to control this for years, so we haven't actually allowed the natural selection of genetically predispositioned animals to fend off parasites. Now, I know ICBF, Irish Cattle Breeding Federation, have started listing last few years. They're getting the factory kill sheets and putting all the data from the liver damage into a central database, and that feeds back then into the sire and dam, and we know what sires then are more susceptible to liver fluke. So it is measurable, but the problem is getting that input from other parasites. But the liver fluke one is easy to manage. But what we're looking at on our own farms is the adaptive immunity. So that's the immunity that gets triggered when they come up against the parasite. So that's why we need to control the amount that they're coming up and face against. And that should give them a certain immunity for life. They'll come up against it every year and build on their immunity. It's a bit like being vaccinated yourself. We all know about COVID vaccines. So you get your 2 shots, and then after that, the odd shot here and there seems to do the trick. But also, because these animals are more susceptible, they're also the factories for these parasites. So as they're walking around the farm, defecating out onto pasture, they're leaving behind them a large number of eggs. So if we're grazing them back onto themselves, coming back 3 weeks later, like I was talking about, the perfect environment, these particular animals are going to become overwhelmed, and that's when we end up getting disease and sick animals and reduced performance. So when we do dose, this is when we do worm our animals. This is my nephew's firefighting hat. So we look at, when we do need to worm them, we do it off of fecal egg counting. So we're testing our animals, seeing what parasite numbers they have. We use the right product, so not combinations when we don't need to. If it's in like a season like this where the flies haven't been a big issue, do we need to be using a parasite control product that also controls flies if we just have stomach worms? The right time, so again, our testing when we need to go in. The right animals, we can actually, if we have weight gains, we can pick out within a group of animals which ones actually need to be wormed. They don't all have to be done. Refugia then, so that's your people that don't think it's acceptable to put pineapple on pizza. That's your refugia group. There's no need to get rid of those. Your dump paddock then, when they are wormed, where they go. So if they're wormed, what I encourage people to do is put them back onto a small area of ground for about 48 hours and leave out all because the product that they're putting out behind them is at its highest concentration at that point. Leave it in that corner of the field and don't put those animals back in there again. So, suppose show me the money. Don't try read this. There's a lot of information. You can take a photograph if you want. It's a confusogram. This is a case study on wormers, costings, on my own farm that I did a couple of years ago. And it's a difference of $3,000, which is not massive, but I think there's other costs there that the risk aversion is a hell of a lot lower, and animal performance has increased. Our milk output on our farm has increased over the last number of years. I'm not making any claims on that. That's to do with genetic selection. But I suppose the point is that what we're doing hasn't actually affected the animal's performance. So why you do all this? Well, when we worm our animals, the wormer kills everything that's reduces the populations of all the insects that are in the dung pat. In doing so, we're removing a lot of insects from our farm. Removing the insects from our farm leaves a lovely sterile dung pat then subsequently for the parasite eggs to increase their populations, and then we start using more wormers, and then we get on this downward spiral. So it's to change that and turn into an upward spiral. So that's why I say many hats at dung poo. We can't look at it from one point of view. There's loads of point of views. There's an ecological point of view, there's a veterinary point of view, the farmer's point of view. I'm putting all this together. So that's me in a nutshell. Happy to take any questions. Thank you very much.